Okay, let's just dive right into this explainer, shall we? We are going to look at how a seemingly abstract geometry concept from a textbook is, well, actually the ultimate life hack for your next DIY project. We spend so much time learning math concepts in a total vacuum. But today, we're looking at a brilliantly practical application of a chapter on symmetry. We're going to take what might seem like a really dry academic principle and turn it into a tool you can use literally today to save time and just get absolutely perfect results. To really understand how this works, let's look at a super relatable situation. Prem and Manu are setting up for Lolly's birthday party, and they want to put up these big, beautiful happy birthday cutouts on the wall. Now, if you've ever tried to cut out giant bubble letters from construction paper yourself, you know exactly the kind of headache they are dealing with. You try drawing it freehand, you cut it out, and suddenly one leg of the A is just twice as thick as the other, or the H looks totally lopsided. It's incredibly frustrating, and honestly, it just wastes a ton of paper. So, that's their big challenge. How do you create perfectly proportioned letters without painstakingly drawing the whole thing freehand with a ruler and compass? Well, instead of doing it the hard way, they have this massive stroke of genius. They actually remember a specific lesson from their grade 4 math class, chapter 10, to be exact, which is all about reflection symmetry and lines of symmetry. And they decide to use this academic knowledge to their absolute advantage to knock these cutouts out quickly and flawlessly. Here is the crucial point. Certain letters, like the letter A, possess what we call a vertical line of symmetry. All that means is if you draw lines straight down the middle, the left side is an exact mirror image of the right side. Because they know this, Prem and Manu realize they only need to complete 4 incredibly simple steps. Step 1, fold a piece of paper right in half. Step 2, along that folded edge, just draw 1/2 of the letter A. Step 3, cut along the outline. And step 4, open the paper up. And wow, this brilliantly illustrates the trick. By just drawing that weird slanted shape with a little notch out of it and making the cut, the fold does the rest of the work. When you unfold it, the mirror image is just automatically generated. You get a perfect, totally symmetrical A every single time. The folds literally act as your line of symmetry, making sure both sides are absolutely identical without you ever having to measure them against each other. It is just incredibly efficient. Now, let's move to the letter H and see how this builds. Because the letter A is great, sure, but the letter H is even better. Why? Because it has 2 lines of symmetry. It's got a vertical line straight down the middle, just like the A, but it also has a horizontal line slicing it right across the center. The top half mirrors the bottom half. So get this, you can fold your paper vertically and then fold it horizontally. Our 4 steps just leveled up. Fold the paper into fourths. Draw just 1/4 of the letter H right along the corner where the folds meet. Cut the outline and open it up. The magic here is just wild. It's so cool to see how this tiny little sketch unfolds into a complete, massive letter. By only drawing an L shape on that small folded square, making one cut and unfolding it, you get a flawless, full-sized H. I mean, you literally did 1/4 of the work, and the geometry of reflection symmetry just went ahead and did the other 75% for you. Okay, I want to pass the challenge over to you for a second. Think about the alphabet. Looking at this specific list from the chapter, E, N, X, T, K, V, and O, which of these letters possess those hidden lines of symmetry? Can you visualize folding them in your mind right now? Which ones could you create by drawing just half or maybe even 1/4? Take a second and just picture where a mirror line would actually go on each of these. All right, let's break down the answers. Letters like T and V have a vertical line, so you'd fold them left to right. Letters like E and K have horizontal lines, meaning the top mirrors the bottom, so you'd fold top to bottom. And X and O, they are the absolute all-stars here. They have both horizontal and vertical lines, meaning you can totally use that 1/4 fold hack on them. But then, there's poor N. The letter N has neither. If you flip it vertically or horizontally, it just doesn't match up with itself at all. So for N, you actually do have to draw the whole thing out. But listen, this explainer isn't just about making alphabet banners. The chapter makes it super clear that this concept extends way, way beyond letters. Think about a butterfly. If you were to draw a line straight down its body, the left wing is a perfect reflection of the right wing. That is reflection symmetry in nature. It's not just a clever trick for cutting paper, it's a fundamental design principle of the world around us. Nature uses symmetry for balance, for aerodynamics, and honestly, just for beautiful design. And once you really get this, you start training your geometric eye to spot these lines everywhere. Whether you're designing a kite, which totally relies on a vertical line of symmetry to fly straight, or you're simply looking at a leaf mirroring its veins across the central stem, it's the exact same mathematical rules that helped Prems and Manu with their birthday sign governing the design of the objects we interact with every single day. Now, just when you think you've completely mastered symmetry, the chapter throws in a fantastic twist. Literally, it's called rotational symmetry. This is where things aren't mirrored or flipped over a line, but instead they're spun around a central point. Basically, a shape has rotational symmetry if, after you turn it a certain amount, like, say, a half turn or a quarter turn, it looks exactly the same as it did before you even touched it. Imagine stamping a design with a carved wooden block, which is actually a super cool project mentioned in the source chapter. Notice how taking that cross-like shape and rotating it just 90 degrees, a quarter turn, locks it completely back into its original appearance. The flower shape works the exact same way. They don't just have reflection lines, they have rotational symmetry. It's a completely different way for a shape to find balance with itself, and it's absolutely essential for creating continuous repeating patterns in textiles, architecture, you name it. So, what's the ultimate takeaway from Chapter 10? Really, it's that symmetry is not just a math concept confined to some dusty textbook. It's the absolute foundation of art, design, and incredible human efficiency. By deeply understanding how reflection and rotational symmetry actually work, Prem and Manu didn't just pass a math test, right? They unlocked a permanent shortcut for life. They learned how to do a fraction of the work to get a perfect whole result. And honestly, that is the very definition of a life hack. So I'll leave you with this to ponder as we wrap up this explainer today. Before you move on to your next task, take just a second and look around your room right now. What everyday objects sitting near you are secretly relying on these hidden lines of reflection or rotational symmetry just to function properly or even just to look appealing? Once you start looking for the symmetry, I promise you, you're gonna find it absolutely everywhere.